Hey guys, today in class we did this mixed factoring worksheet. Now the lesson we had today, for those of you that weren't here, was actually not very long. There were very minimal notes. So instead of creating a whole separate post for the notes for today, I'm going to try to show you some techniques that we talked about very briefly today in this assignment. Okay. The first set of problems here, they're all what we call quadratic trinomials, which means degree 2, but quadratic means degree 2. The highest power is the squared, or the 2, and then they all have 3 terms. Okay. Now the techniques or methods that we use for factoring these are similar, but they differ slightly depending on A, basically, or what we call the coefficient of the quadratic term. So if you recall, recently we talked about standard form for a quadratic, and we gave it these letters A, B, and C to represent whatever the coefficients were for the terms. So A, when we say A, we're talking about this A. We're talking about the coefficient of the squared term or the quadratic term. So I've put here to decide, before you even start, decide if it's 1, if it's prime, or if it's what we call composite. And composite basically is the opposite of prime. So prime is a number that's only divisible by itself in 1, like 7 or 23. Composite has other factors besides 1 in itself, like 8 or 24 or something like that. Okay, so I'm going to show you some new techniques here that will make factoring a little bit faster, but also keep in mind that there's techniques that I've already taught you that you can use on these as well, and we'll talk about both as we go. Okay, I'm going to start out with number 2 here, and I'm going to do 4 and 6. So I'm just going to do the evens. You have an answer key that will help you with the odds if you need to check yourself. But we'll use these as examples for what you're going to do kind of over here. So the first thing we're going to do is we're going to look at the quadratic trinomial, and we're going to figure out what A is. Okay, in this case, A is equal to 1. Since we don't see a number in front of that x squared, we're going to assume that that's actually a 1. So A is equal to 1. I'm going to write that because that's part of the question. Okay. The other thing we're going to do is we're going to factor it now. So our factoring will change a little bit based on what A is. In this case, it's 1. So what I'm going to do here is I'm going to find A times C, right? Remember, this is B, this is C, and then A, of course, we already talked about is 1. So A times C would be 1 times 10, or 10. Now notice in this case, since A is 1, A times C is the same thing as just C, but that's okay. Okay, and then B is 7. And anytime I do this cross method with this little cross here, the two numbers that go here have to multiply to 10, and they have to add to 7. So if you think about the factors of 10, you got 1 and 10, those add to 11, and you got 2 and 5, and those add to 7. So it's 2 and 5. Okay? Now what we do with these two numbers completely depends on what we have for A. Okay, now if A is 1, which it is, I can take those two numbers and I can put them directly into my final answer. Right? I know my answer is going to be 2 linear binomials. We know that from inductive reasoning, basically the patterns that we've been talking about the last couple weeks. And the 2 and the 5 go straight in there. Okay, so that's how I would manage a quadratic trinomial when the coefficient here, the A, is 1. All right, let's look at number 4 now. Okay, now in this case, you'll notice that it's not 1 anymore. It's a 3 this time. And if we can factor out that 3, that's going to be our first choice. So I'm going to look to see if these are divisible by 3. 45 is, but 32 is not. And so I can't take out that 3 the way I want it to. Okay, so what I'm going to do is I'm going to say A is, probably not equal sign, A is prime, right? And that's going to make kind of a difference for me here as well. So I'm going to go ahead and make my little cross just like I did up here. I'm going to multiply A times C just like I did up here. It's going to give me a 135. I'm going to put B down here just like I did before. Okay. And now we're going to look for factors that multiply to 135, but when I combine them will give me a negative 32. since they're going to both multiply to 135, and that's a positive number, they either both have to be negative or they both have to be positive. In this case, I know they're both negative because they combine to give me a negative number. So I'm looking for two negative numbers here. Okay. So what I'm going to do is I'm going to start finding factors of 135 and see if they work. Okay. Now, I told you guys before that you can kind of do it systematically by starting with 1. Right? So 1 times 135. Those are not going to work, though, because if I put a negative 1 and a negative 135, that's much too big to be this number. So we're going to kind of keep going. 2 doesn't go in, but I believe 3 does. It's 3 times 45, because we did 3 times 45 to get there. If I combine these two, negative 3 and negative 45 is negative 48, so that's not going to work. Let's try 5. So I'm going to grab my calculator here and make sure this, I know it's divisible by 5. I'm just going to double check what that is. Okay, it's 27. So a negative 5 and a negative 27 will give me a negative 32. So those are the two magic numbers. Okay. Now yesterday, what we did is we took those two numbers and we broke apart this trinomial into a quadrinomial, and that's what we're going to do here as well. So remember, when a is 1, those two numbers go straight into my final answer. When a is not 1, those two numbers, we have to do something different with them. We can't just put them in our final factors. We have to actually change our polynomial a little bit. So I put the negative 27 first because that has a common factor with 3, and I'm going to put the 5 next to the 45 because those two have a common factor as well. Okay. Now from here, you can factor by grouping, and we did that on last night's homework, so you should know how to do that. You group these two, the common factor is 3n, you pull that out. You group these two, the common factor is negative 5, you pull that out. When you do that, you're left with an x minus 9 in both cases, so you factor that out. All right, that's grouping. Okay, but I'm going to try to show you a different way of doing this, and kind of coming back to this idea of analyzing what a is. All right, now I'm going to start with what my expected answer looks like. When we have a quadratic trinomial, we can pretty much bet it came from two linear binomials if it does factor. So we're expecting two linear binomials. And what we're going to do is we're going to go through one piece at a time, and we're going to make sure that we have the correct pieces in order to give us these 4. One of the things we talked about yesterday is when we take this trinomial and we break it into 4, this is basically our f, our o, our I, and our L in FOIL. Now remember that the order of these two may be switched if you take these two numbers and you put them in the other way. So there's a little bit of flexibility with the two middle terms. You can like rearrange them. And usually it's smart to rearrange them in a way that these two have a common factor that's not like 1 or n, and these two have a common factor that's not 1 or n. Okay, so we're just going to go one term at a time and make sure that I can get the 4 correct pieces to my two binomials here. Okay. Now this seems like it's going to take a little longer because it's new, but in the long run this is much faster than grouping. Now of course if you want to, you can still do grouping, but I would recommend trying this to see if you can get faster. So let's start with the f. Okay. To get the f, f stands for first. So it's this guy, whatever's in this position, times whatever's in this position. So these two things have to multiply to 3n squared. Okay. Now because it's n squared, I know I have an n here and an n here. And this is the other key. Because a is prime, there's only one way to factor 3. It's 3 and 1. Right? There's no other options because it's prime. So I know for sure that one of my terms up here has to be a 3n and the other one has to be a 1n. That's the only possibility to get me a 3n squared. So that's kind of nice. We actually want it to be prime if that's possible. Actually, ideally it's a 1. But if it's not a 1, then the next best option is that it's prime. So right now I have just put two things in here that will guarantee me to get the correct f term. These two numbers will get me 3n squared. So I'm like almost unfoiling here. I'm trying to figure out what these have to be so that when I FOIL, I get these guys, and then when I combine like terms, I get this. We're just going backwards with FOIL. Okay, now let's check my outside term. So outside would be this guy and this guy. Okay, when I multiply these two guys together, I should get a negative 27. And notice that 27 is a multiple of 3, so that makes sense. 3n times some number is negative 27, and it turns out that's a negative 9. So now I've got 3 terms in there, or 3 pieces in there, and my O matches up. So I have the right O now. This here will get me back to this guy. Okay, now next I check my I. So I stands for inside, or inner, that's these two guys, the ones on the inside. And when I multiply these two, I'm supposed to get a negative 5n, and I have an n here. So that means that this must be negative 5. Okay, so now I've made sure I have the correct I term. When I multiply my 2 inside guys, I get this. Okay, now L stands for last. I have already got all 4 in there, so I'm just going to double check now. Is negative 5 times negative 9 actually 45? It is in this case, and so this is what we got. So again, grouping will work here. From here, you can totally group it. And this took a minute because I had to explain it, step by step. But really, once you're like, okay, what are my possibilities for f? It's got to be 3n and n. Cool, done. Now, with that being the case, with that being a 3, how do I get a 27? Okay, I need a negative 9. Okay, cool. How do I get a negative 5? I got an n here. Okay, I need a negative 5. And then that kind of thing. You can go from there. So we're going to do that one more time. We're going to do it in number 6 now. But the difference here is that now we have a composite number. Okay, so we'll talk about that in a second as we go. Just remember that composite is like non-prime. Okay, so 3, its only factors are 3 and 1. 10, we have the factors 10 and 1, but we also have the factors 5 and 2. So it's what we call composite, non-prime. All right. So what we're going to do is we're going to start by doing our box. Okay, and we're going to multiply 10 by negative 42. It's going to be negative 420. Okay, on the bottom, we're going to have negative 23. That's B. And then we're looking for these 2 magic numbers. Okay, so what I'm going to do is I'm just going to start listing factors of 420 until I find the right 2. Now I know that one of these is positive and one of these is negative because they multiply to give me a negative number. I also know that the negative one has to be bigger because when I combine them I get a negative number as well. So I want to show you another hack here. If you're doing this systematically, it will work and you won't miss anything. 1 times 420 is 420. If one of them's negative and one of them's positive, that would give me like a difference of 419, either negative 419 or positive 419. And notice that number is way, way too big. So if I try to like make one of these positive and one of these negative, when I put them together, I'm looking for a negative 23, but I'm getting a negative 419. So the trick here is that the closer these 2 numbers are together, the closer these are to each other, the smaller this number will be. Okay? So if I put these 2 together, again, making sure one's negative and one's positive, I'm going to get like a 419. That's way too big. And so instead of going from 1 and going up the chain, I'm going to jump ahead to numbers that are closer to each other, right? So maybe try like 10 and 42, for example. Okay. Now if I have a negative 42 and a positive 10, the difference between those is 32, which is much, much closer. Okay, so by skipping a whole bunch, I got closer to the difference that I'm looking for. Okay, now again, the smaller this number is, the closer these will be to each other. And these are too far away. So let's try, I don't think 11 goes in, let's try 12. So 42 divided by 12, whoops, sorry, it's 420 divided by 12, is 35. And those are actually 23 apart. So, Jeopardy bell. All right, so these are the 2 magic numbers I need. All right, so that's like a little hack to get faster. If this number is relatively small, then try numbers that are closer together. Okay, if this number is huge, try numbers that are farther apart. Okay. All right. Now from there, what we're going to do is we're going to take our trinomial and we're going to break it into a quadrinomial. So I need a 12a and a negative 35a. But I'm going to put the negative 35 closer to the 10 because those have a 5 in common. And I'm going to put the 12 closer to the 42 because those have a 4 in common, I believe. Okay. So I went from here to here, right? I split the 23 A term into this and this. Okay. Now you could group from here. You could totally group factor by grouping. So group these two, pull out a 5a, group these two, pull out a 4, and then go from there. But I'm going to try to show you again this new way. So remember that this is the F term, the O term, the I term, and the L term. So what we first got to do is we got to figure out the two pieces that we need that will give us the right F term. Whatever's here and whatever's here will multiply to 10a squared. So it's got to be something with an a and something with an a. But because this is composite, or it's not prime, we have options, because it could be 10a and a. That will give us the right F term. But then again, it could be 5a and 2a, because those will also give me a 10a squared. So the question is, which is it? Well, this is how you figure it out. Okay. Later on in this process, I'm going to have to get an O, right? Now, these may be like reversed. I might have these in the wrong order, and that's okay. We'll figure it out if we need to. But the idea is whatever's here will eventually multiply whatever's here to give me one of those two things. Okay? So let's go back for a minute. Let's try it. Let's put the 10 in there, because we weren't sure which one it was. Could be 10 and 1 or 5 and 2. Okay. If I have a 10 here and I multiply this, then whatever I get is going to be a multiple of 10, right? So 10 times whatever has to give me either this term or this term. I'm not sure which one. But if you think about it, 35 is not a multiple of 10, and neither is 12. In other words, there's no way to get this term or this term by multiplying by 10. And so I know for sure that this can't be a 10a, because one of these has to be a multiple of whatever I put here. So this is not a multiple of 10, this is not a multiple of 10. Okay, so it's for sure not going to be 10, and we can eliminate that as one of our options. Okay, next we're going to try the 5 and a and the a, or sorry, it would be 5a and 2a. And we just want to double check before we move on that these two, each of one, sorry, let me say that again. One of these has to be a multiple of 5, and one of these has to be a multiple of 2. We have to make sure that that is actually going to be the case. So when I look at this one, I'm like, okay, negative 35, that's a multiple of 5, that will work. And 12 is a multiple of 2. Okay, so I think this is going to work. And 5 and 2 were my only other options. So now I'm sure that I got the right F, guys. F, the first term of this binomial and the first term of this binomial will have to multiply to give me 10a squared. I know for sure I got the right two, so I'm going to check off F. Okay, from here, now that we have these set, it's just dominoes. Everything falls into place after this. Okay, remember that this term, or maybe this term, again, the order, these are a little bit flexible. One of these terms has to come as a multiple of 5. 5 times something has to give me either one of these. It's got to be this one, because this is the multiple of 5. So 5 times what will give me a negative 35? It's got to be a negative 7. So 5 times negative 7 will give me negative 35a. Okay, so that takes care of that. Okay, now let's double check to make sure I can get the right I term. That's I for inside. So 2a times whatever is here has to give me a 12a. That looks like it's going to be a 6. Okay, so that's okay. And now we have to double check L, our last. So last term of the first binomial times the last term of the second binomial, 6 times negative 7. That does give me a negative 42. So this is my answer. Okay, now again, that probably seemed longer than grouping because it's new. But when you get fast at that and you go through those possibilities in your mind really, really quickly, you can actually skip some steps, right? So it's like, okay, what has to go here? Could it be a 10? And a 1, well, that's not a multiple of 10, and neither is that. Okay, so it's not that. Can it be a 5 and a 2? Well, that's a multiple of 5, and that's a multiple of 2, so that's what I have. Boom, put them in. Okay, once those are set, how do I get a 35a? 5 times what? Okay, negative 7. Boom. Okay, how do I get a 12a? 2a times what? Boom, 6. Okay, cool, got it. Does that multiply to a negative 42? Yes, it does. Boom. Check it off the list, and you're good. So you can practice those techniques down here later on because there's lots of trinomials to practice. You don't have to use those techniques, but those are going to be the ways that are going to get you there faster. Okay, the surefire way of doing it is this grouping. Like if you get to this 4-term polynomial, you just do grouping from there. And you are welcome to do that as well. Okay, let's go through some of these. Okay, we're not going to go through all of the evens here, but we'll go through a few of them. Now these ones say factor each polynomial completely. And this right here is a key word. When it says completely, that means all the way, which means there might be more than one step. Okay, for example, if I take 60 and I factor it into 10 and 6, I factored it, but I haven't factored it completely. So what I need to do is I need to keep factoring until I can't go any further, right? So now it's factored completely. The same is true for polynomials, okay? So factor completely is a hint that there's probably more than one step. And the first step is always look for a GCF, a greatest common factor. Okay, if there's a common factor that we have, we can pull it out. That will make our lives easier. So in number 8, we look at this guy and we notice it's not quadratic. It's got a degree 4. But you also might notice that all of these have at least 2 m's. They also all have a factor of 3. So I can undistribute a 3m squared. And when I do that, I'm going to have 3 terms left over from these 3 guys when I pull them out. So if I take 3m to the 4th and divide it by 3m squared, I'm left with m squared. If I take negative 6m to the 3 and I divide out 3m squared, the negative 6 divided by the 3 is a negative 2. And then if I have, 3 m's being multiplied and I divide 2 of them out, I'm left with 1 of them. Okay, now this piece is a little tricky. If I take 3m squared and I divide it by 3m squared, you're like, oh, it cancels. But what do we mean by cancel? In this case, we mean it's going to give us a 1, because 3m squared divided by 3m squared is 1. So if we're factoring a GCF out of a trinomial, we should end up with a trinomial. And so we have this 1 as kind of a placeholder. So what originally looked like a pretty gnarly problem, pretty hard problem with high powers, is actually fine, because now we're just worried about this guy. We're just focusing on this trinomial. So the 3m squared is going to be part of our final answer, but for now we can ignore it, and we're just going to focus on the trinomial m squared minus 2m plus 1, right? So what we do is we look for that coefficient, right? We figure out what that number is. In this case, it's 1. So we do our x method. We put 1 times 1 up here, negative 2 down here, and we're looking for 2 numbers that multiply to 1 but combine to negative 2. The only way we can get a positive number from multiplying is if both of them are positive or both of them are negative. I know that these are both negative because they combine to be a negative 2, and it looks like it's going to be a negative 1 and a negative 1. So remember, going back to number 2 up here, when our a is 1, or the coefficient of the quadratic piece is 1, these 2 numbers will just go straight into our final answer, our final factors right there, okay? And since this is kind of the same thing, right, m is 1, we're going to do the same thing. Now, of course, we started out with a 3 there, but remember we factored it out, so that's already taken care of. Now that we're focusing on this smaller problem here, we can consider the a, the coefficient of this term, to be a 1. So I'm going to have 2 trinomials here, or excuse me, 2 linear binomials, and it's going to be m minus 1 and m minus 1. These 2 numbers go right in there. Since those are the same exact binomial factor, I can just say that it's m minus 1 squared if I want to. That's an option. All right. So most of these are going to be trinomials, right? This is a trinomial. This is a trinomial. Most of them are going to be multiple steps, so you're going to have to factor out the GCF first and then go from there. Some of these are binomials, and we'll take a look at a few of those as well. Let's go ahead and do 10, and we'll go from there. Okay. So when I look at all these numbers here, I know for sure that x goes into all of them, and they're all even, so 2 definitely goes into them. I think 4, I know 4 goes into this. I'm pretty sure 4 goes into this. Let's see if 4 goes into 102. Okay, so that doesn't work. What else would go in there? Maybe 6? Yeah, 6 goes into this and this. Maybe it goes into 102 as well. Okay, that looks pretty good. We got to make sure that there's nothing bigger. For 42, I think we have 6 and 7, and then we have like 21 and 2, but 21 doesn't go into that, and I don't think it goes into that. So I'm pretty sure 6x is my greatest common factor. All right, when I pull that out, I get a 7x squared plus a 17x, remember when we divided by 6, got a 17x, and then a 6 at the end. Okay, so that's step 1. Now we've factored, but we haven't factored completely because we have to find out if this thing factors. And that's kind of our next step. So we're going to do the little, this guy, okay? 7 times 6 is 42. We got a 17 in the bottom. Okay, so we're looking for factors of 42 that combine to give me a 17. If we start with 1 and 42, those are too far away. We can try 2 and 21. Add those together and we get 23, so we're getting close. If we divide 42 by 3, that's going to be 3 and 14, and those are the, sorry, couldn't see that. Those are the two that I need. So 3 and 14 add to be a 17. Okay, so remember we factored out the 6x, that's going to be part of my final answer, but right now we're only focusing on this trinomial. That's all we're focusing on. Once we get that, we're going to put those next to the 6x we already have, and we're going to be good. Now keep in mind that this is prime, so when I factor just this part, the 6x is going to be down here later, there's only one option for the first terms of these binomials. It has to be 7x and x. 7 doesn't break down any other way. It's got to be a 7 and 1. Also, since it's x squared, we have an x here and an x here. So that's kind of a nice thing. Now, sorry, I was going too fast here. It is going to be a 7x and a 7x, but let's talk about these two numbers. That's probably what we should do, 3 and the 14. Sorry, 3 and the 14. So what we're going to do, let's take the 7x squared and keep it there, and then we'll take the 17x and we'll make that into a plus 14x and a plus 3x and a plus 6, right? So I forgot that step, kind of jumped the gun a little bit. Remember the 6x is just down here. We're just focusing on what's inside the parentheses. So 7x squared is here, 6 is here, the middle term breaks down. Okay, so from here, you could factor by grouping if you wanted to, which a lot of people do, because these have a common factor of 7x and these have a common factor of 3. You could do it that way. But there's a quicker way to do it, which we talked about today, and I'm going to demonstrate that for you. Okay, so going back to what I said just a minute ago, this has to be a 7x and an x in these binomials. That's the only way I'm going to get a 7x squared. Okay. Now from there, which of these is a multiple of 7? It's this guy, right? Okay. So 7 times what is going to give me 14x? Better be a plus 2. Remember, this is my f, this is my o, this is my I, this is my l. Okay, now this guy right here is going to come from x times something. All right, so x times what is 3x? Better be a 3. Okay, and then just double check the last term. Is 3 times 2, 6? Yes, it is. Sorry, 12. I'm going to write over you. All right, so that's my final answer there. Okay. All right, now again, from here, if you're like not sure how that worked, you can use the grouping method. In the long run, it's not as fast. If you can get used to doing what I showed you here, kind of setting your first terms and then kind of figuring out what the next ones have to be based on these 4, that's going to be faster in the long run. All right. Okay, so we got a bunch here on the back. Really, it comes down to practicing. The more you practice, the more you'll start recognizing stuff. You're like, oh, hey, I've done that before. I've multiplied those two numbers before. But the first step always on any factoring problem is check to see if there's a greatest common factor. Okay, do that first, and then you'll be in pretty good shape. Okay, so what I want to do now is I want to start focusing on some binomials, because we've done several trinomials already. We've already done 4 trinomials. So let's look at some binomials. Okay, when we're factoring a quadratic binomial, pretty much the only way we can do that, besides taking it a GCF, is to see if it's a difference of squares. Okay, so we've seen lots of these before. Let me give you a simpler example. When you see this, you're like, ah, that's 7 squared, right? And so remember when we saw these quadratic binomials, like the middle term's gone. We don't have the x term. We have the x squared term, we have the number term, but the x term is missing from the middle. And that only happens when we have matching binomials with the same number inside but different signs, right? So x minus 7, x plus 7, or excuse me, x, sorry, let me erase that better. X plus 7, x minus 7. What's going to happen here is the negative 7 and the negative 7x and the 7x are going to cancel, so I'm not going to have any x terms, but 7 times negative 7 is negative 49. So we call that a difference of squares binomial. Difference of squares, difference meaning subtract. That's x squared, that's 49. And we write it as a conjugate pair. Okay, so let's do another one really quick, and then we'll go to this one that's a little bit harder. So let's say we got 36. Okay, so you might notice that 36 is 6 squared, right? Okay, so this is a difference of squares. So what we do to get the pieces that we need for our conjugate pair, which is, again, the same binomial but the signs are different, we call that a conjugate pair. We're going to take the square root of x squared, that gives us x. We're going to take the square root of 36, that's 6, and those are the two pieces that we need in our conjugate pair. We're just going to make sure that one of the 6's is positive and one of the 6's is negative. All right, now that's exactly what we're going to do here, although this is a bigger number, that's okay. The question we might ask ourselves is this a difference of squares? Well, let's find out. Let's take the square root of x squared. Well, that's x, obviously. But what's the square root of 625? Well, we can prime factor it if we want to, break it down. But, you know, at this point, now that we've practiced that a bunch of times, let's just see what we get. Okay, that actually came out nice. So the pieces that we're working with are an x and a 25. These are the two pieces in our... Sorry, I spaced out. These are the two pieces in our conjugate pair, right? So just like this, x plus 6, x minus 6 will give you this. X plus 7, x minus 7 will give you this. X plus 25 times x minus 25 will give you this. So when we see a difference of squares, or something that we think could be a difference of squares, we're just going to take the square root of both pieces, and if we get something nice out, then we're going to set up a conjugate pair, identical binomials, but one's going to have a plus and one's going to have a minus. So conjugate pair is kind of like twins, like conjoined twins. Right? Think of it like that, conjoined twins. This is the good twin, this is the evil twin. So in a conjugate, you have a 1 plus and a 1 minus, but otherwise they're the same. All right, let's look for some other binomials here. Okay, take a look at this one, 17. Now what we probably should have done on 13 that we didn't is check for a greatest common factor. The reason that I didn't is I could tell right off the bat, this doesn't have a number in it other than 1, and this doesn't have an x in it, so they don't have a greatest common factor. Now that we have multiple sets, we've got to think to ourselves, can anything go in here or in here? Or is there a common factor, in other words? And the answer is no, there's not a common factor. So we're going to think, is this a difference of squares? Well, this is 5 squared, and this is 4 squared. So let's set up our conjugate pair. Let's take the square root of 25n squared. Okay, altogether that is 5n. And if I take the square root of 16, that's 4. So these are the two building blocks of my conjugate pair. I need a 5n plus 4, and I need a 5n minus 4. Whoops. Got a little too excited, boxing my answer. All right, cool, so that's not too bad. A lot of these binomials are pretty fast. Okay, let's do 18. Okay, now this is tricky because you're like, oh, that's not something squared, but it actually is. Okay, check this out. If I take the square root of x to the 4th, remember the root is a root 2. So anything that has a power of 2 can get out of the jail. Well, I can rewrite this as x squared times x squared, right? Because I can just break down the 4. So the 2 here cancels with this 2, and I get an x on the outside. A 2 here cancels with this 2, and I get another x on the outside. Or in other words, x squared. So the square root of x to the fourth is actually x squared, which is kind of interesting. The square root of 16 is 4. And so these are the two pieces that I need in my conjugate pair. I need an x squared plus 4, and I need an x squared minus 4. So even though that looked kind of different than number 17, it's actually very similar. These are both differences of squares. That doesn't look like something squared. It looks like something to the fourth power. But think about this. If you do x squared and you square it, that will give you x to the fourth. So it actually is a power of 2. All right, now there's actually one more piece to this because remember it says factor completely, which means there might be more than one step. So when I look at this guy, I'm like, that's factored completely. That's a quadratic binomial, but like I can't do anything there because of that plus. But this guy is another difference of squares, right? It's x squared and 2 squared. So you're like, oh, a difference of squares inside a difference of squares. Okay, well, let's just keep going. So this can't factor. That's just going to stay here. But this guy, if I take the square root of x squared, that's x. If I take the square root of 4, that's 2. So the building blocks that I need here are x plus 2 and x minus 2. In other words, I can go a little bit farther. This one can break down into 2 more. This one can't. So these are my my 3 final factors. So that's kind of a funky one because it's like excuse me, difference of squares inception. A difference of squares inside another difference of squares. Which is crazy. Okay. Let's do a couple more binomials and I think you'll probably be good. Let's do number 22. All right. Again, always check for a greatest common factor first. Keep forgetting to do that, but up here, that doesn't have a coefficient and that doesn't have an x. So I kind of just right off the bat recognized there was no GCF. I didn't mention it, but that's what I did there. Okay, now here I have a number out here and a number out here, and it's kind of hard to see what goes into both of them. They're both even, so definitely a 2. I don't think 4 goes into this one, and I don't think 6 goes into this one, and 8 doesn't go in, and 10 goes in, but 10 doesn't go into this. So it looks like 2 is going to be the greatest common factor. So when I take out that 2, I'm left with this guy. Okay, so that's step 1. Now this is now a difference of squares because that's 5 squared, and that's 9 squared, and this is x squared squared. It's kind of weird. So I have a 2 at the bottom. That's my greatest common factor. Let's focus on this guy. 25x to the fourth minus 81. Let's take the square root of that and the square root of that. Okay, the square root of 25x to the fourth is 5x squared. Right? Remember, I can break this up into x squared and x squared, and then bring out an x and bring out an x. So that's 5x squared. Square root of 81 is going to be 9. So these are the 2 building blocks I need in my conjugate pair. I have a 5x squared plus 9, and then I have a 5x squared minus 9. Now I can't go any further because this isn't a difference of squares. It's pretty close, but a 5 isn't a perfect square. And in this case I have a plus, so I can't go any further there. So factor completely means like keep going as far as you can go until you can't go any further. All right, now I'll give you a hint. Some of these are prime, which means you can't factor them at all, but there's only a couple. There's one of them also that the only thing you can do is take out the greatest common factor, and then you can't go any further outside of that. You'll kind of know that if there's nothing you can do. Like if you are trying to factor the trinomial and you do the x method and you try and try and try and try and you've tried every possibility and you can't find 2 numbers that multiply to this and combine to this, then you're like, okay, it doesn't factor then. In which case you would say it's prime. So we kind of talked about that in class the other day, but 2 of these in problems 7 through 24, 2 of them are going to be prime. One of them, the only thing you can do is factor out a GCF, and then you're stuck from there. So just kind of keep that in mind. The rest of these, we got a couple binomials here. So looks like you have a greatest common factor of 4. Take that out first. This one is, I think, do I have that one twice? Oh, I have that one. Oh, no, it's very similar. Not quite similar, but this one has an x squared and this one has an x to the fourth. So you got some differences of square binomials, you got some trinomials. Okay, so practice, practice, practice. Check your answer key. Make sure you're on the right method. Factoring just takes practice, and the more you factor, the more you start to recognize, what goes into what, and you get faster at it. So, hope that helps. I will see you guys in class, and thank you for watching.